In last session, we were discussing about the binomial expansion. We did up to this question, how do we supposed to find the percentage and how to find the approximate value for that. So today we'll be starting with this question today. So the question is given as 1 over a plus bx equals to 3 plus 1 over 3x plus 1 over 18 x squared. Find the value for a and b. Right, okay. And the next question is find the coefficient of x cube. So initially, I'll just expand this this 1 over a plus bx to the power half using binomial expansion. Make a question this way. That is 1 over a plus bx, the square root of it. It's equals to question 1 plus 1 over x plus 1 over x plus 1 over 3x plus 1 over x squared. Yes, yeah. So initially we need to find the value for a and b. That is a fact where we have to find it. Let's see how to do this question. So you can say this is a plus bx to the power minus r. Then I'm using the usual binomial expansion for this. If I use the binomial to apply the binomial expansion, this value should be 1. Therefore, I have to take a out. If I take a out, you can say this is 1 plus b over a x, all thing to the power half. So this one you can say a to the power half times of 1 plus b over a x to the power half. Hope you can understand how I get it. Up to this section, if it is not clear, please ask. Yes, hopefully it's fine. Then I'm just doing this expansion for this a to the power half. This is 1 plus b over a x to the power half. Then you can say this is, if I just expand this, it's turn up to a to the power half times of this is 1 plus n x ax. So this is b over a x over factorial 1. Then let's go to the next one. Next one is n is half, n minus 1, half minus 1 is minus half. So this is bx over a whole thing squared divided by factorial 2. The next one is n.
That should be minus half, no?
Where?
In the second
Yes.
step.
Yeah. It's like this. So I just made a mistake. It's minus half. It's minus half. Then it should be, this is minus half, but this is minus half, and this is minus half. Minus 1 is put a minus 3 over 2. This is minus half minus 3 over 2, and the next value is minus 5 over 2. Why I'm getting up to x to minus 5 over 2 times of b x over a whole thing cube, because we need to find the up to x to the power 3. The reason is that over here in next part of the question, they need to find the coefficient of x cube. So you have to do this expansion up to here. That is required for us to do it. Right? Okay. So let's go ahead a little bit of it. I'll just, without simplifying, just keep this answer as it is. Later on, I can simplify. Minus half. So this is turn up to 1 minus b over 2ax. And if you simplify this, it's turn up to minus 1 into minus 2 is plus 2 plus 3 or 4. It's turn up to plus 3a squared, 3b squared over 3 into 2 into 2, 4 to 2 is 8a squared x squared. Then if you do the simplification, this is 2 into 3. So this is turn up to minus half into minus 3 over 2 into minus 2 over, minus 5 over 2 divided by factorial 3. It's turn up to minus 5 over 16. This is turn up to minus 5 over 16 a cube x b cube a. Sorry, this is b cube a cube x cube, right? Okay. Then if it is work out over here, but this is 1 over a to the power half times of 1 minus b over 2a x plus 3b squared over 8a squared minus 5 over 16. Sorry, this is x squared should be here. B cube, a cube, x cube. Right. Okay. Plus it goes to infinity, but you just need to write only this part of it. Right. Then if you work out over here, the first number, this is similar to 1 plus this bit. Therefore, you can say either if you expand it like this, 1 over a to the power half times of 1, that is the first term, which is exactly similar to the term over here. Which is similar to the exact term over here. Therefore, you can say this is 1. With this information, you can, if you simplify this, you get the answer. A to the power half is equals to 1. Therefore, a becomes 1. So simply you can get the answer for a. Then if you equate the coefficient of what do you call that? Now you know that value for a over here. Okay? Then so this now it's reduced into 1 over 1. If I just do this, 1 plus b over 2x plus 3b squared over 8 x squared minus 5b cube x cube over 16. That is a now you know that a is equals to 1. Therefore, this is reduced into this. Then if you equate the coefficient of x, so you can say this is b over 2x. The b over 2, because if you get the constant terms over here, the constant terms equate, you get this answer. So you can get the x terms. B over 2. From this side, what is coefficient of x is 1 over 3. Turn up to then 1 over 3. Turn up to 1 over 3. Therefore, you can simply say b is equals to 2 over 3. Now you've got the answer for b as well. The next part of the question, they ask the coefficient of x cube. What is the coefficient of x cube? We know that that is minus 5b cube over 16. That's part B answer. I think, yeah, the question part B, hopefully, yes. I'll find the coefficient of x cube. These are for A. This is equals to then, you can say minus 5 over 16. B value we already found is 1 over 3. 1 over 3 cubed. So you can say this answer is 5 divided by 16 into 3 to the power 3 is 27. That's turned up to 5 over 432. Would be the final answer for this. I just little bit minimize this, then you can see the entire answer at once. So this is a way of doing this question. I hope you can understand. Anyway, I just put into the video so you can get this one from that. And with the meantime, I'll send you the worksheets as well. Right, okay. Then that is that part of the answer today. Then, yeah, if you come up with this question today, fx equals to 3 plus 2x minus x squared or 4 minus x, prove that if x is sufficiently small, fx can be approximated by 3 over 4 plus 11 over 16x minus 5 over 64x squared. Let's see how to do this question. Yes, Pute. This is yes. Yeah. Okay. Okay, Pute. Then for this question is chapter 4, binomial expansion. Question number 7. Yes. Yeah. 1 second. Yeah, that's it. Then let's go to the question. Then, according to this fact, what they have given is just like this. The question is, but the fx is equals to 3 plus 2x 3 plus 2x minus x squared over 4 minus x. 4 minus x, you should be able to write in the form of they ask you to show that it's similarly 3 over 4 plus 11 over 16x minus 5 over 60 4x to the power 2. That's a way of they asking this question. So initially what you need to do is, while keeping this one, you cannot apply the binomial expansion. So initially you can see that the numerator is kind of bigger than the denominator. The numerator is kind of bigger than the denominator. And or you can write this format in this format as well. 3 plus 2x minus x squared times of this one, you can say 4 minus x whole thing, 4 minus x to the power minus 1. This is not a binomial expansion. This is just a already expanded version. Therefore, we have to operate this fact initially. So I just write 4 minus x to the power minus 1. So to make them into binomial, universal binomial expansion, this should be 1. So I can take 4 out. 1 minus 1 over 4x to the power minus 1. So that is turned up to 4 to the power minus 1. 1 minus 1 over 4x to the power minus 1. So this is turned up to then 1 over 4, 1 minus 1 over 4x to the power minus 1. So it's turned up to 1 over 4. I'll just expand this. 1 plus n. N is minus 1 ax minus 1 over 4x over factorial 1. So you need to write up to x to the power 2 only. So there's nothing to worry. Minus 1, minus 2. This is minus 1 over 4x whole thing squared over factorial 2. Like this, it goes on to that. So with this, you can say it's 1 over 4. This is 1 plus 1 over 4x. So this is minus plus, it's done up to plus. Yes, it's plus. Plus 1 over 16x to the power 2. Yeah. Plus it goes till infinity. Then if you do this expansion, it's turn up to 1 over 4. 1 over 4 plus 1 over 16x plus 1 over 64 x to the power 2, like it goes on. So that is only the expansion of this bit. Therefore, what you need to do is, you can say this is 3 plus 2x plus, sorry, minus x squared times of this bit. 1 over 4 plus 1 over 16x plus 1 over 64x to the power 2. Then what you need to do is, we can expand it. So initially, I'll just multiply everything with 3. So it's turn up to 3 over 4. This is plus 3 over 16x minus, sorry, plus 3 over 64x to the power 2. Right. Then I'll multiply everything with 2x. 2x into 1 over 4 is 2x into 1 over 4. That is 2 over 4. I just write later on, you can simplify. 2x into 1 over 16 plus 2 over 16x to the power 2. 2x into x squared is x to the power 10. No need of writing it, because we need to write the expansion up to x to the power 2 only. Minus x squared into 1 over 4 is minus 1 over 4x squared. If you write it vertically, it's easier for us to simplify. That is why I'm just writing in this format with it. Right, this is turned up to then 3 over 4 plus, if you add these two together, 3 over 16 plus 2 over 4 is 11 over 16x. If you just simplify, it's turn up to minus 5 over 64x to the power 2. That is the answer for that. So that is the way of doing this kind of situation. Right. Okay. Yes.
Sir,
Yeah. Yes, Pute. Yeah. Why? Yeah.
sir, now like what kind of what is the question like now මෙහෙම දුන්නොත් we might think it's division like will they say like binomial expansion or something?
I didn't get it, Pute. What do you mean?
Like at first, what if we think this is a division?
Yes. So initially, this is what if you want, you can do as a division and you can get it beyond. Yeah, that's a very good question. You are right. So if it is, if you write it as a, if you think it as a division and if you do it, how do you supposed to rectify that situation whether you get the same answer or a different answer? That is your problem, hopefully, right? So yeah, it's a good approach. So you can say this is 2x. So you may think that yes, whether can't you do it with the division? Just make copy work out 4 minus x. So if you do this division, it's not converted into a binomial expansion like this because look at this. If you do this division, this is the way it comes. Yeah. So I'll just do the long division. Minus x squared plus 2x. This is minus x. Yeah. 2x plus 3. You have to divide by minus x plus 4. Then you have to see whether how many minus x terms or minus x squared. That is x. Then x into x is minus x squared. X into 4 is 4x. If you subtract it, you get the answer. This is 0 to minus 2x plus 3. Then you have to see whether how many minus x terms of minus 2 is plus 2. Then 2. 2 into is minus 2x plus 8. So it's turned up to minus 5. Now this one reduced into this format today. X plus 2 minus 5 over 4 minus x. Right. Then we can write this is x plus 2 minus 5 times of 4 minus x to the power minus 1. Right. Then you can write this is x plus 2 minus 5 times of we know 4 minus x to the power minus 1 expansion we already learned. So just a little bit small, then you can just see the both answers at once. Yeah, it's little bit of small. Yeah, here we already learn the expansion of this bit. 4x to the power this bit. So that is turned up to 1 over 4. It's 1 over 4 plus 1 over 16x plus 1 over 64x squared. Yeah, okay. Let's do this and see whether we can reach to the same approach as the answer. So this is turn up to x plus 2 minus 5 over 4 minus 5 over 16x. This is 4. Sorry, not 4. That was 1 over 64. Yeah, 1 over 64. Plus 1 over 64. The minus 5 over 64 x to the power 2. Yeah, so if you do this, 2 minus 5 over 4 is how much? 3 over 4. X minus 5 over 16x is how much? 11 over 16x minus 5 over 64 x to the power 2. For that one, even you get the same answer. Is that clear, Oshadi? Yes. Oshadi, are you there? Right.
Yes, sir.
Yes, right. That's great. Now, is that clear? Have I get this answer?
Yes, sir, it's clear.
That's great. Okay. Then the next fact is how to use this, what do you call that, partial fractions to obtain a binomial expansion. Later on, I'll use the boundary conditions at the end. partial fractions for binomial expansion. That means, Pute, if it is a question, if you come across a question somewhere like this, yeah. So if you happen to do this kind of a fact application over here, 8x plus 4 divided by 1 minus x times of 2 plus x. They ask you to expand using the partial, sorry, they ask you to do the binomial, you have to expand this. If you don't want to expand this, what you need to do, you have to put 8x plus 4 times of 1 minus x to the power minus 1 binomial 2 plus x to the power minus 1 binomial. Suppose that if you need to find expansion up to x to the power 3, there are two terms are there. There are then 1 minus x to the power, there should be 4 terms comes. There should be another 4 terms comes. Then you have to multiply all of these terms and you will get into 6 into 6, 16. 16 plus 2 into 18 terms. Sorry, 16 into 2 is you have to write 32 terms of the expansion to get the final answer. It's quite big. So in this situation, is that clear what I mean today? So if I want to write it up to x to the power 3, so there is only 2 anyway. X to the power 3 means x to the power 0, x to the power 1, x to the power 2, and x to the power 3. There should be 4 terms comes over in this expression. Here also the another 4 expression, another term from a 4 term expression comes. So altogether you have to do a multiplication of how many terms? 4 into 4, 16 into 32 terms. It's quite big. And it's have a lot of chance to making any what do you call that errors when you are working out with this. That is why if we have this kind of situations, we use these partial fractions to obtain the answer for the binomial expansion. This is the way of doing it. Initially, you can do the partial fraction for this. 8x plus 4 over 1 minus x 2 plus x. So I write it as a over 1 minus x. Hope you can remember how we get this answer. 2 plus x. Then you can say 8x plus 4 is equals to a times of 2 plus x plus b times of 1 minus x. Right. Okay. Then you can write this one as if you consider if you make the x equals to 1, it's turned up to 12 and 3a. With this answer, you get the answer a is equals to 4. Then if I make x equals to minus 2, minus 16 plus 4 is minus 12 is equals to 1 minus minus 2 is 3b. Therefore, b become minus 4. Then easily, what you can obtain here is today, you can write this one, you can write in this format. You can say 4 over 1 minus x plus minus 4 over 2 plus x. Right. Now you can use the binomial expansion to do this expansion. Then this is turned up to 4 into 1 minus x to the power minus 1 minus 4 into 2 plus x to the power minus 1. So initially, I will just do this expansion. I'll just get it. This is the part we have to subtract. Okay. Then if I get 1 minus x to the power minus 1, how is it supposed to do with it? This is 1 plus n x over factorial 1 plus n minus 1 divided by factorial 2 n minus 1 n minus 2 divided by factorial 3. Right. So this is turned up to then 1 plus x squared plus x to the power 3, like it goes on. That's a way of getting this answer. Then if I want to get this part of it, that's the first part of it, you can say. Right. Okay. Then this is turned up to 2 plus x to the power minus 1. That is, if I take 2 out, 1 plus 1 over 2x, all things to the power minus 1. So that is turned up to 2 to the power minus 1 times of 1 plus half x to the power minus 1. So that is turn up to 1 over 2, 1 plus half x to the power minus 1. Right. Then you can do this expansion. Okay, so it's turn up to 1 over 2, 1 plus n. N is minus 1 into 1 over 2x over factorial 1, n minus 1. Factorial 2, n minus 1, n minus 2 over factorial 3. Like that it goes on to there. Right. Then if you do this, it's turn up into half. So this is turn up to minus 1 over 4x. And this 2 turn up to, yeah, 1 over 4x squared. Yeah, I think it's okay. So it's not 1 over 4, it's 1 over 2. Sorry. Yeah. So if you multiply, so initially, yes, I think I will erase this and we'll do it from the beginning. Yeah. Then put this is minus 1 over 2, this 2 get cancels. Minus 1 over 2 into 2 is 1 over 4. 4x, right? So these 2 cancels with this 1 over 4, it's 1 over 8. 1 over 8 x to the power 2. So it's minus, so it's turned up to minus 8 to 16, minus 1 over 16 x to the power 3. Like it goes on today. So that is how you do this expansion, right? Okay. Now what you need to do is, we can say this answer is 4 over this, 4 into this, and minus 4 into that. So you can say this, the final answer is 4 into 1 plus x squared plus x cubed minus 4 times of 1 over 2 minus 1 over 4x plus 1 over 8x to the power 2 minus 1 over 16x to the power 3. Like that it goes on to this. So like it's going with this. So it's turned up to 4 minus 2. It's 2. 4 4 plus 1 is 5. 4 minus half is this bit. 4 4 plus 1 over 4. 4 plus 1 over 4 is 17 over 4. X cubed. Like that it goes on with this kind of expansion. That's a way of doing this kind of a expansion using the partial fractions. Is that clear? I just minimize this for you to see the entire question at once. Yeah. So make a chuttak like this is a question. So that is that is why we need to use a partial fraction to obtain this kind of a solution. So if you happen to find any kind of partial fractions, you should be able to use this fact to get the final answer. Is that clear, children? Oshadi, is that clear? Madhushani, you all there? Madhushani, is that clear for you?
Yes, sir.
Yes, okay. Yes, Pratik, right. And then quickly, let's go to the last question. The same fact of it. So if it is given as this kind of it, this kind of function, 2x squared plus 7x minus 6 plus 7x minus 6 divided by x plus 5, x minus 4. X plus 5, x minus 4. So initially, Pute, if there is a fraction like this, if the power of the numerator is equal or greater than the power of the denominator, you have to use the long division before the partial fractions. Pute. They ask you to do the what you call binomial expansion for this. 7x minus 6 has to be divided by x squared plus x minus 20. Right, then you can use the long division. Pute. So you just do it here, 2x squared plus 7x minus 6 divided by x squared plus x minus 20. So it's turned up to 2x squared plus 2x minus 40. If you just subtract it, 0 plus 5x minus 34. Yeah, sorry, plus 34. Yeah, I think it's okay. Yeah, right, okay. Then you can write this expansion in this way. So you can say this is 2 plus 5x plus 34 over this bit. X plus 5, x minus 4. Then you can say, I'll just initially, while keeping this format, it's kind of hard for us to do it. So you have to use the partial fraction for this to simplify this. X plus 5, x minus 4, you can write this is a times of x plus 5 plus b times of x minus 4. Okay. Then this is, then if you work out, it's done up to 5x plus 34 is equals to a x minus 4 plus b x plus 5. The denominator, see the denominators are same, you can equal the numerator. So you can just write this expansion for it. Then if x equals to minus 5, then it's turned up to minus 25 plus 34 is minus 9 is equals to minus 9a. With that, you can get the answer a equals to 1. Then if I put x equals to 4, 20, 54 is equals to 4, then what? 9b. Therefore, b is equals to 6. So you can write this answer as a is 1 over x plus 5 plus 6 over x minus 4. This is okay. I put 4 here, yeah, 9b, 4 here, 20, 34, it's 54. That's great, okay. Then this is the expansion for that. Now you have to do the expansion for this. So that is, you can say 1 times of, you can say this is x plus, then you write this way, 5 plus x to the power minus 1 plus minus 4 plus x to the power minus 1. That's a pointer to understand. So you can say this is, you can take 5, this part I'm going to do it, 5 plus x to the power minus 1 is turned up to 5 to the power minus 1 times of 1 plus 1 over 5 x to the power minus 1. So this is 1 over 5, 1 plus 1 over 5 x to the power minus 1. Do the expansion for this. Then this is, you can take minus 4 out, minus 4 to the power minus 1 out. It's turned up to 1 minus 1 over 4 x to the power minus 1. So we have to make them into 1. Therefore, you have to take minus 4 out. If you take minus 4 out from this expression, it's turned up to minus 1 over 4 to the power minus 1. So minus 4, this is turned up to minus 1 over 4. And this is 1 minus 1 over 4x to the power minus 1. Then you can do the binomial expansion for these two separately. And you can see, you can get this expansion today. This expansion, whole expansion, and this whole expansion. Then there is another 2 at the front. When you do the partial fraction, that there's a 2 over here. There, what you need to do is we have to submit 2 plus the first bracket plus the second bracket should be added to that. That's a way of doing this kind of situation. So there's another part of it. So sorry, this is turned up to 6. So it should be 6. There should be 6 over here. And there should be another 6 over here. With that only, you have to do it because that 6 should be added to the expression. Or you can do this expression over here without 6, and at the last end, you can add the term for that. That is a way of doing this question. So you just try this exercise, and yeah, you can do exercise 4C as well.